going to go and focus on the ambiguous case, the side-side angle, where two triangles exist and we want to find those missing pieces. All right, so here's our example. We give you angle A, side A, and side B. And I've already drawn the pictures to these two possible scenarios. I want to just go back and refer to this piece of our chart for the ambiguous case. So we're going to find the height. So remember, height equals B times the sine of A. So we're going to plug in our B, which is 31, our sine of A, which is 20.5 degrees. And let's find that height. So use your calculator, plug in 31 times the sine of 20.5. And you get a height of 10.8. Now, this is true right here. Our height is smaller than our A, and A is smaller than our B. Remember, height is about 10.8, our A is 12, and our B is 31. So we have two triangles. So I've drawn the picture to these two triangles, and we're going to go ahead and find these missing pieces. So the first piece is angle B. So we're going to use the law of sines, and I call this B1. So I'm going to say the sine of 20.5 degrees, which is angle A, divided by side A equals the sine of B over side B. And we're going to go ahead and use our cross multiplication. So we get 31 times the sine of 20.5, 12 times the sine of B. Divide both sides by 12, so you get 31 sine of 20.5 over 12. You'll get a decimal value. So 31 times the sine of 20.5, divide that by 12, and you get 0.9047. To be able to find that angle measure, we want to use inverse trig. So we say B equals the sine inverse of that decimal place, 0.9047. So second sine, 0.9047. And we get an angle measure of approximately, I'm just going to round it to the nearest degree, make it a little bit easier for this example. So 65 degrees. So I'm going to go ahead and put 65 degrees in. Now, we know two angles in our triangle, so we can find angle C by the triangle sum theorem. So we take 180 degrees minus 65 degrees minus 20.5 degrees. So 180 minus 65 minus 20.5 is 94.5 degrees. Now we know angle C1. To find side C1, we would use the law of sines again. And I'm just going to set it up. You would say C over the sine of C equals, let's just say B over the sine of B. And then you'd use your cross multiplication and find that. I think we've done enough of the law of sines. You're probably comfortable with finding that last side. All right, let's shoot over to the other side of this video side, where we have that same angle, the same side, and the same side. So we want to find B2. Here's how you find B2. What you have to do is you have to take 180 degrees and subtract it from angle B1. Remember, angle B1 is way over here at 65 degrees. So we say 180 degrees minus 65 degrees. And we get 115 degrees. So that's this angle here. Now again, we can use the triangle sum theorem to find that angle C2. So we take 180 degrees minus our two given angles now of angle A and B to find that angle C2. Which is 44.5 degrees. So angle C2 is 44.5 degrees. Now the last piece that we don't know yet, again, is side C2. We would use our law of sines and find side C2. So we'd say side of C over sine of C. You can use side A again if you wanted, over sine of A. And you cross multiply and solve for C. And that's how you use the law of sines when you have two triangles existing in that ambiguous case.